Hey, what's going on, folks? It's Mike here, and welcome to our Deep Programming Language series. In this lesson, we're going to continue talking about functions, which we've been talking about previously in the series, so make sure you check out the playlist if you haven't seen those. And we did a little bit of a divergence in some of the previous episodes, talking about things like ampersand, and this is going to be useful in this lesson just so you can sort of debug what's going on. Because what today we're going to be talking about is pass-by-value and pass-by-reference semantics, or at least get a little bit of an introduction. So again, if you're coming from a language like Java or C++, you've likely heard of these things, but if you're coming from C, or again, if this is your first programming language, likely you might not have heard of some of these things. So with that said, let's go ahead and dive in and see some examples. So just to get you ready, go ahead and go to the documentation, language reference, down to functions here on the left side. And I'm going to bring you down to what is category 15 here, and then it's going to be the reference parameters here. So just go ahead and do a little search for that if you want. There it is, again, highlighted. I'll move this over to the side and just bring it here. And this can be something that you read. I'm going to show you an example. But what I really want you to be familiar with, again, was this idea of us talking about this thing, the program stack, previously. And this was the idea that when we call a function, for instance, that we're making copies of our arguments. So whether those are arguments in main or some other function that we're calling. So this is a good picture to have in your mind here as you're thinking about this. But again, I'll give you a tool so you don't have to necessarily think about this explicitly. All right, so I'll leave the help page there. But actually today we just mostly want to look at some source code. So today I've got an example set up for us. I'll walk us through it slowly, and let's just go ahead and start from the main function, our entry point in the program. So let's go ahead and center ourselves here. And all this program's doing right now is creating a local variable here. It's an integer 5, and I'm just going to print out the address here. Now I'm converting here this address to a string representation so I can concatenate it with this string here. That's all that's going on, and just writing an empty line. Now go ahead and rerun this, as you can see I've done here. And all it's doing is saying the local in main is, well, this at this address here. And just to confirm here, if you want, it might also be useful to just print out the actual value here that's stored, and it is indeed 5. So there should be nothing mysterious of at least this amount of code here. Now, what I am going to ask you to do now is to take a look at this example, and I'm going to uncomment out this function here called Passbyvalue. And that's this block of code here. Passbyvalue, I take in one argument here, the integer, and I'm just going to do a printout so we know where we are. I'm going to modify this argument here, and then I'm going to write out the address of this argument, just so we know exactly where this is located. And now what I want you to do is think about what is this local variable after we call the passbyvalue function. And I'll go ahead and give you a moment to think about this. Let me just go ahead and save this code. And if you'd like, pause the video and make a prediction as to what's our local going to be. And with that said, let's go ahead and run this, see if your prediction's right. And when I run it, well, the local is still 5. So even if I change that value when I call this function here, passbyvalue with local, so again, that's our variable here, after the fact, well, the variable doesn't change here. Again, I'm printing it out exactly here after our function call. Now, why is that? And we can do a little bit of investigation and just sort of understand the semantics, again, of what happens when we make a function call. So again, when I pass in local here at line 24, and I call this function, I'm making a copy of this variable. And we can sort of prove this with this little experiment here where I write out the actual address here. So this is the passbyvalue argument address, which is here. And if you observe, it's different than, well, what our actual local's value is. So again, let me just go ahead and run this again, just so you can see that, even just comparing these last 3 numbers, which is usually how I do this quickly, you can see that these are different values. So that means the thing that I'm modifying in this passbyvalue here must be different. The thing that I'm changing to 9999. So that's, again, what happens here. And I want you to go ahead and pause and think about this. And if it's useful, I'll leave this diagram up here from our previous lessons. Because remember, whenever we make a function call, we are copying those arguments and getting a new copy here in our stack frame. And then it goes away after our function call. So it would make sense that we're just sort of modifying something temporarily, writing out, the address of this temporary value here, and not modifying our local at all. So that's what it means when we pass by value. And sometimes this is actually called, and I'll write it up here, which is probably a better name for it, pass by copy, or pass by copy value, pass by copy value. That's how it used to be known as. And again, that's just the sort of one of the defaults when you're passing simple types like integers, floats, and so on into a function in D. Now, here's where things get interesting, because we might want to actually modify the information that we're sending into a function. Because, well, what if I actually want to modify this integer variable? Now, I've named this pass by reference, and you'll sort of get the hint here that I'm going to pass by reference. In ref, what that means here, if I can sort of summarize here on the whiteboard, let's go ahead and do pass by value and pass by ref here. Pass by value, we make a copy. Therefore, or I should sort of say with the 3 dots here, no modification to argument. And pass by reference, well, I'm going to kind of give you the hint here. We are referring to actual variable address, and I'll put in parentheses just by a different name. And sometimes we just think of this as an alias of the name. So again, just a different way to sort of call something. Okay, so that's the idea. So with that in mind, let's think about the same experiment where if I modify this arg, but I add in ref here, that I'm referring to the same thing. If we see that this is the same address of our local variable that we're printing out here, then it must be that we are in fact modifying this argument here and setting this value to 9999. Okay, so let's go ahead and do that experiment here. I'll go ahead down into our code. I've got it here. And again, let me go ahead and just give you a moment to pause and think about this. What's going to happen this time when I do pass by reference here? And then we print out the value of our local. Well, again, if this is in fact referring, because we're using the ref qualifier here on our argument, then we should be in fact modifying and setting local to 9999. But I'll let you think about that a little bit. And hopefully you've paused and thought about that. I'll go ahead and hit enter. And voila, we in fact do get 9999 here. And again, just to confirm our experiment where this ampersand operator is helpful, if we look at the actual address of this argument here, which is here, the pass by ref arg, as indicated, we're just writing out, and then on a new line, the address here. This value is the same address as our local in the main here. So in fact, again, we are modifying this variable. So this is a way that we can explicitly modify a value if we're passing into a function. So a better name for this might be, for instance, if I was going to write this in real code, I would just call this set value or modify value or something like that. Again, using a good verb to sort of name or explicitly say what's going on here. Versus this, I might just say, print value or something like that so that we know not to modify it. Now, what's sort of interesting here, why use this sort of ref keyword? Well, again, we have to think about what cost we are making here, or rather saving ourselves from. So when I'm referring to the actual variable, I don't have to make a copy of it. Okay, so that's an important thing to summarize here. So I'll go ahead and say avoids, and I'm going to write this in green because it's important, avoids a copy. And I'll put an exclamation mark. That's a good thing for performance. Saves us on performance. So when we call our function, we don't have to be, modifying things. Now we haven't talked about things like the const keyword, which would be a way to sort of, if we weren't modifying this actual data, be able to use that data. And again, that would be another purpose. Instead of having to make a a full copy of this data. Okay, so that's some things to keep in mind. Okay, so I'll just go ahead and run that one more time so you can see it. Now, in the deprogramming language, we can use ref explicitly, but something else that we do have to think about, and will be for another video, is reference types. So I want to go ahead and quickly just show you a little experiment here, where if I create an array here, and let's just go ahead and append to this array the value 5, for instance, and then let's write a function here called do something with array. It's going to take in a integer array. I'm just going to call this arg here. And let's see if we actually modify the first argument to 9999, what happens here. So let's actually call do something with our array. And then I'll actually right line the array at index 0 here. Okay. So this I want you to think about a little bit here, this little snippet of code here. So I've got do something with array. I'm not using ref here, but I am modifying whatever the first element is here in our array. Okay, so let's go ahead and run this. And well, the first thing that I write out here is, in fact, 99999. So this we do have to think a little bit about. In fact, I'll just go ahead and put a little note here. And that was a perfect cue, if you hear the sirens in the background, for think about this. But this idea that, well, sometimes, or some data types, in fact, arrays that are dynamically allocated, and I'm going to talk about this in the next video just so we have a clear lesson on it, those actually get passed by reference by default. Okay? Now, why does that sort of make sense? Well, it has to do with where is this actual data being allocated in our dynamic array, if it's on the heap or the stack. Okay, so we know if it's a copy and something that should be copied or not. So even if I put the ref keyword here, it's still going to work the same. This is just the default behavior. If it makes you a little bit happier to put ref here just so it's very explicit, that's fine. But by default, arrays are passed by reference. And again, this is one of the powers of a deprogramming language. It is a systems programming language, and it gives you some of this control. Now, again, if you just need to use the values here, or if you actually wanted a copy, there's things in the standard library to actually .copy or .duplicate this actual array and get a copy of it that you can modify and use for some purposes. So I just want to throw that out there. But with that said, folks, I hope that's sort of putting things together here as to why we've kind of gone back in the previous few lessons and done some of this deep dive on stack and heap, and now thinking about when are we copying data, or when are we able to just actually use that data. So we've added to our sort of toolkit here the ref keyword for what we'll call value types, things like integers, floats, structs, which we're going to learn about later, and that there is a little distinguishment between things like arrays. And I'll talk about that in a future video, so make sure you subscribe, etc., so you don't miss that if you're enjoying this series. Otherwise, comment below if you have some more questions about that. That'll be more than happy to try to answer, or someone from our community will. And with that said, thank you for your time and attention as always, and I'll look forward to seeing you in the next one.